to projects. In this video, we are going to explain about the project, which is a proposed method for detecting network intrusion using deep learning approach. Introduction of the project. The project addresses the persistent threats faced by computer networks, emphasizing the constant risk of security breaches, infiltrations, and unauthorized access. The network serving as a repository for authorized user resources also attracts malicious users seeking to exploit these valuable assets. Recognizing the severity of security breaches, the project underscores the importance of adopting preventive measures to protect organizational interests. It discusses the diverse types of attack networks that are susceptible and acknowledges the implementation challenges associated with the effective protection policies. Network intrusion detection systems are introduced as a crucial tools in identifying and thwarting hostile network activities. It delineates three types of intruders who are masqueraders, mischievous, and those attempting clandestine activities, and stresses the need for systems capable of detecting both external and internal threats. Recognizing the evolving landscape of security threats, the project discusses the remarkable improvement in machine learning algorithms. It notes the emergence of software defined network implementations as a new frontier for NIDS deployment, particularly in the light of the escalating security risks posed by technologies like artificial intelligence, quantum computing, and Internet of Things. The project emphasizes developing an efficient NIDS using machine learning approaches, particularly anomaly detection and deep learning methods. It focuses on the NSL-KDD dataset to create a data-driven approach for categorizing patterns in legitimate and malicious network activity, employing neural network models for their ability to handle diverse parameters. Objective of the project. The objective is to improve intrusion detection accuracy in computer networks, providing a more robust defense against cyber threats for the benefit of network administrators and security personnel. The goal is to reduce the need for manual intervention in intrusion detection process, aiming to save the time and resources for organizations while enabling security teams to focus on the strategic tasks. The objective is to introduce a deep neural network model for intrusion detection utilizing advanced deep learning techniques to enhance the sophistication and effectiveness of network security systems. The goal is to employ the NSL-KDD dataset to train the intrusion detection model, benefiting researchers, cybersecurity professionals, and organizations by contributing to knowledge advancement and the development of robust security solutions. The objective is to showcase the potential benefits of the deep learning approach for network intrusion detection systems by presenting a method that outperforms previous projects. This aims to provide a benchmark for organizations seeking for more effective intrusion detection solutions. To implement this project, we need software and hardware requirements. Coming to software requirements, we need application of Anaconda, primary language of Python, front-end framework of Flask, backend framework of Jupyter Notebook, database of SQLite 3, front-end technologies of HTML, CSS, JavaScript, and Bootstrap 4. Coming to hardware requirements, we need operating system of Windows, processor of i5 and above, RAM of 8 GB and above, and hard disk of 25 GB and above. To implement the project, we have designed various steps in the flow of work. The first step is importing the packages. In this module, necessary Python packages and libraries are imported. We have imported pandas for data manipulation, NumPy for numerical operation, Matplotlib and Seaborn for data visualization, scikit-learn for machine learning, Keras for deep learning, and Flask for web development. The next step is exploring the dataset. This module involves loading and exploring the NSL-KDD dataset. Initial steps include understanding the structure of the dataset, checking for missing values, and gaining insights into the distribution of different features. Data processing. We convert the raw dataset into Pandas data frame for easier manipulation and analysis. We use Pandas functions to create a structured data frame from the raw dataset. We prepare the data for training using Keras by transforming it into a format that is suitable with neural networks. We utilize Keras functions to pre-process the data. We remove unnecessary or redundant columns that do not contribute to the modeling process. We use pandas to drop columns that are not relevant for the analysis or modeling. Visualization using Seaborn and Matplotlib. Utilizing Seaborn and Matplotlib, this module involves creating visualizations to better understand the dataset. This includes plots like histograms, pair plots, or heat maps to reveal patterns, correlations, and potential outliers. Label encoding using label encoder. Categorical data is often encoded into numerical format for machine learning models. The label encoder is applied to convert categorical labels into numerical values. Feature selection. Feature selection is crucial for building efficient models. This module involves selecting the most relevant features using select percentile, which is a method based on statistical tests. Splitting the data into train and test. The data is split into training and testing sets. The training set is used to train the machine learning model while the testing set is reserved for evaluating its performance. Building the model. In this module, deep learning models are constructed. This involves defining the architecture of the neural network and choosing the specific algorithm for traditional machine learning. The next step is training the model. The model is trained using the training data set. This involves feeding the input data to the model and adjusting its parameters to minimize the difference between predicted and actual outcomes. The next step is Flask framework with SQLite for sign up and sign in. This module integrates the Flask web framework with an SQLite database to implement a user sign up and sign in functionality. This involves creating routes and views for user registration and authentication. User gives input as feature values. User input feature values through the front end of the application. This information is then sent to the server for further processing. The given input is pre-processed for prediction. The received user input is pre-processed to ensure that it aligns with the requirements of the trained model. This involves data cleaning, encoding, and scaling that match the format used during the training. Trained model is used for prediction. The pre-processed input is fed into the trained model to make predictions. The model leverages the learned patterns from the training phase to provide an output based on the user's input. Final outcome is displayed through frontend. The predicted outcome is sent back to the frontend and displayed to the user. This is in the form of classification result. Algorithms which are used in the project are deep neural network. Deep neural network is a type of artificial neural network with multiple layers between the input and output layers. These networks are characterized by their depth, featuring several hidden layers that enable them to learn intricate patterns and representations from the data. DNNs excel at capturing complex hierarchical relationships in the data. DNN is employed for intrusion detection in the project due to its proficiency in automatically learning complex patterns and relationships from the raw data. The deep architecture allows effective handling of the increasing complexity of the network activities, ensuring accurate detection of anomalies and potential security threats. DNNs excel in generalization to new and unseen patterns, providing adaptability to evolving cyber threats. The end to end learning capability streamlines the intrusion detection process, making the DNN a powerful tool for enhancing precision and efficiency in network security. As an extension, we applied an hybrid model to produce more robust and accurate final prediction. Also, as an extension, we built the front end using Flask framework for user testing with the user authentication. We evaluated this project using different performance metrics, which are accuracy, precision, recall, and F1 score. So here we have comparison graphs for all those metrics. This is accuracy comparison graph. Here on x-axis, we have accuracy score for each algorithm, and on y-axis, we have algorithm names. Accuracy is a measure of the overall correctness of the model. It calculates the ratio of correctly predicted instances to the total number of instances. Here we have precision comparison graph. Precision is the ratio of correctly predicted positive observations to the total predicted positives. It evaluates the accuracy of positive predictions. This is recall comparison graph. It is also called as sensitivity or true positive rate. Recall measures the ability of the model to capture all relevant instances. It is the ratio of correctly predicted positive observations to the total actual positives. This is F1 score comparison graph. It is the harmonic mean of precision and recall. It provides a balance between precision and recall, especially when there is an imbalance in class distribution. The algorithm which performs well among all these metrics will be used for final prediction. To execute the project, first we need to open the code folder which contains source code files. This is the code folder of the project. Here in this folder we have NSL KDD dataset which we use for training the algorithms. This is static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap files. This is templates folder. This folder contains all the HTML pages used in the project. It typically includes files like index.html, about.html, etc., which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content that to be rendered in the HTML templates. This is the model file which contains the algorithm information and that will be loaded into the project code during runtime. Here we have notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for the data science. Here we have signup file, which is signup.db file. This file is a database file used to store the user information. Now we need to copy the path of the code folder from the address bar of the file explorer. So I'm copying the path. Now we need to open the Anaconda prompt. Using the cd command followed by the space, we need to paste the copied path and then click on enter. This will change current directory to the code folder's path. Here we need to type the command which is python space app.py and then click on enter. This will compile app.py file and execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, Flask framework will host the application locally at the default address, which is the local host and the port unless configured differently. So this is the local host and this is the port. Now we need to copy this local link provided by the framework and paste it in any web browser. So I'm copying the link. I prefer Google Chrome, so I'll paste it in that. So I'm opening Google. Here we need to paste the link and then click on enter. This is the web page of the project which is displayed in the browser, and this web page is built by using the Flask framework. Here we can see a sign up link. First we need to click on that. Here we need to enter all the sign up details if we are signing up newly. I have already signed up, so we will directly sign in. For that we need to click on sign in. Here we need to provide our credentials, which are the username and the password. So I'm giving my username and the password and now click on login. We have logged in successfully and we are redirected to prediction page. Here we can see the parameters which are need to be entered. Based on the given parameters, we will get the prediction, which is attack is detected or not. If the attack is detected, it will detect which type of attack. Before entering the parameters, first we will understand them. So here we have protocol type. It is a set of rules and conventions that define how the data is exchanged on the network. It identifies the communication protocol used in the network activities such as TCP, UDP, or ICMP. Here we have service. It is a network service or the application that operates on top of a specific protocol. Here we have flag. It is a signal or the indicator used in data packets to convey specific information. Here we have SRC bytes, which are source bytes. These are the number of bytes sent from the source in a network communication indicating the data volume. Here we have count. Count is the number of occurrences or the instances. Here we have SRV count. It is the number of occurrences of a specific network service or the application in the dataset. Here we have same SRV rate. It is the proportion of occurrences where the same network service is observed, indicating the consistency of a service usage. Here we have different SRV rate, which is different service rate. It is a proportion of occurrences involving different network services, highlighting diversity in service usage. Here we have different host SRV count. It is the number of occurrences where different hosts are involved with the different network services, indicating diverse service utilization across hosts. Here we have destination host same SRV rate. It is a proportion of occurrences where the destination host uses the same network service, providing insights into the consistent service usage at the destination. Here we have destination host different SRV rate. It is a proportion of occurrences where the destination host uses different network services, indicating variability in service usage as the destination. Here we have destination host same SRC port rate. It is the rate at which the same source port is observed at the destination host, providing insights into the consistency of source port usage. We understood the parameters, so now we will enter them. So the protocol type is 0, service is 13, flag is 9, source bytes are 8, count value is 1, SRV count is 1, same SRV rate is 1, different SRV rate is 0, destination host SRV count is 2, different host same SRV rate is 0.5, destination host different SRV is 0.75, Destination host, same SRC port rate is 0.5. Now we will click on predict. Based on the given parameters, here we got the prediction as there is an attack detected and the attack type is where's client. Now we will enter the parameters again but with the different values. Click on home. So I entered all the parameters. Now we will click on predict. Here we got the prediction as there is no attack detected and it is normal. Now we will enter the parameters again. Click on home. I entered all the parameters. Now we will click on predict. Here we got the prediction as there is an attack detected and the attack type is Neptune. Now we will enter the parameters again. So click on home. So I entered all the parameters. Now we will click on predict. Here we got the prediction as there is an attack detected and the attack type is port sweep. Similarly, if we enter all the required parameters, based on the parameters, we will get the predictions of other type of malicious attacks. So now click on sign out. Conclusion of the project. The project showcases a transformative impact of deep neural networks on intrusion detection, benefiting network administrators and fortifying computer networks against evolving cyber threats. By reducing reliance on manual intervention, the project enhances operational efficiency, saving time and resources for organizations and enabling security teams to focus strategically. The use of NSL-KDD dataset refines intrusion detection training and contributes to broader cybersecurity knowledge, fostering a proactive stance against emerging threats. Comparative analysis establishes a benchmark aiding organizations in evaluating the effectiveness of intrusion detection solutions and setting a standard for excellence. The project's findings guide cybersecurity professionals in developing more effective network intrusion detection systems. Future scope involves defining deep learning approaches to address novel cyber threats, ensuring the continual improvement in network security measures.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.